Hi guys, how are you all? So today we are going to explore a design pattern which is known as circuit breaker design pattern. A pattern which is used in multiple distribution system for cascading failures. Okay, so let's imagine a scenario. Let's suppose you are a CTO of a company, Zomato, and your app is getting a lot of orders from the customers. Okay, and the orders are flooding into your app. Multiple orders are coming one by one, and suddenly your payment service goes down. The payment microservice starts responding, and it becomes starts responding zero, and within a minute the entire system grinds to halt, and thousands of customers who are angry for the food, who are hungry, and they are not able to do the payment and losing your money in the seconds. Okay, so what went wrong there? So this is here circuit breaker pattern comes into picture. It is inspired by electrical circuit breakers in your home to prevent electrical fires. Okay, which is the miniature circuit breaker MCB. Whenever the load comes, it trips down, and when it trips down, it stops taking all sort of load on the system, and the surface is failing, preventing your entire system from crashing, your electricity system. Okay, so design patterns initially are the made patterns, which are the patterns which are most commonly used into coding industry to make a solid principle approved, dry principle approved, KISS principle approved, and YAGNI principle approved patterns, which are used to make the code robust. Okay, and design patterns into which circuit breaker is one of them, which is the cascading failure scenario arises. Whenever cascading failure scenario arises, it comes into picture. Imagine a second scenario. Let's suppose we have a Google Meet, and when you have if you I don't know whenever you have seen that scenario, but let's suppose your internet goes down, or there are power breakdown, or there are power issue at your system, and their Wi-Fi goes down. Now in that scenario, your Google Meet starts reloading again and again. It reload 2 to 3 times, 4 times, 5 times, and after that, when the internet comes, it again kick you back into the meeting again. So the thing which you have lose during that time is already loosened, but whenever a connection is established, you are back into the meeting. Okay, so this is also a circuit breaker pattern. So how it again retries again and again, and see whenever a connection is coming, when a connection it connects, and it gets you into the meeting. Okay, so this is the service circuit breaker design pattern use case. Okay, so the circuit breaker design pattern introduces a proxy between services that monitors for failures. It has three states: closed, which is normal operation; open, which is circuit broken; and third is half open, which means testing the recovery, which was doing the Google Meet while the internet goes down. Okay, so close basically means request pass through normally. If error exceeds a threshold, it trips to open. Okay, so it sees that speed is very less, speed is low, very low. So in this scenario, it makes the system open. Okay, if speed is normal, it makes the system close. Okay, for the open scenario, all requests immediately fail without calling the problematic service. Okay, after a timeout period, it switches to half open, and now half open is a limited number of test requests are allowed through. If successful, the circuit close again. If failure, it returns to open. So again, it was checking once, 2, 3, and whenever circuit goes connected, it start connecting, and A and B sends the data to each other. Okay, so into food delivery app also, there is a normal operation, payment service processing orders normally. There is a problem detected into payment service and starts timeout. Okay, where the customer was not able to send the uh, payment, was not able to do the payment. Okay, now circuit opens, app temporarily disable the online payments, offer cash on delivery only. In this scenario, this is whole setup by circuit breaker design pattern, where if online payment fails, cash on delivery is the only option. Majorly it happens into the night. Circuit breaker pattern gives the online payment option only. Cash delivery is stopped. Okay, and then testing recovery. After 5 minutes, system tries a few test payments at the backend again and again to see if it is able to do payment. It is able to do payment. It is able to do payment, and whenever the payment is successful, its system restored again and service is restored again and payment service work again. Full functionality returns. Okay, now the beauty of this approach is fail fast, no waiting for timeouts. It reduces load on the struggling service. It provides self-healing mechanism also, which was we doing again and again, and protects the overall system health. Okay, so this is the circuit breaker design pattern basic idea, and this is the best practice for consideration. When implementing circuit breaker design pattern, we most commonly use appropriate thresholds number, which we majorly test through K6 for the EKS, Vegeta for the APIs part. Vegeta is the open source test scenarios, which is able to test data, okay, for the API for the threshold. The timeout periods, the retry timeout based on the service recovery patterns that also come through Vegeta or the load test, the fallback mechanism, and monitoring the alerts and the testing. Okay, so if we conclude this all together, the circuit breaker pattern is having an immune system for the distributed application or the microservices. It isolates failure, prevent cascading issues, and enables self-healing. Okay, next time whenever we design a microservice, remember circuit breaker pattern is the just to save your system during the big holiday rush, or even if we want to order multiple days, big billion sale days also, and many more importantly, it might save your weekend from being interrupted by production incidents. Okay, thank you.